Well, hello and welcome to our third video for homework this week. If you have already done the practice problems 5 through 8, you will have noticed that all of those answers had either square roots or cube roots in the solutions. Now notice this group is called your nth root group. So you would have a third root or a cubed root, square root. You could have the fifth root, seventh root, etc. Like we talked about with the other group. Our examples and the practice problems, we're really just going to stick with square roots and cube roots. But this would apply to the higher powers and like the fifth root and stuff as well. So just like with the last group, the higher powers, I want to get ultimately the y by itself. That is our ultimate goal as always. However, with that y is not just by itself within it, it is, but it's got some things going on around it that we're going to have to get at first before we can get y by itself. So once we have this kind of squared off, we can see a little bit clearer that I'm going to need to first add 2 to both sides to get us started. So now x plus 2 is equal to the cubed root of y minus 7. And just like where in the last problems we wanted a higher power, the cube root, to cancel those two out, we're going to do the same thing here, but you still have to do it to both sides. So in order to cancel that cube root out, I want to take it to the third power so that those can cancel out. And I'm going to do the exact same thing to the other side, to the third power. So now x plus 2, that's an x, all to the third power is equal to the cube root, and taking it to the third power canceled that out. So we now have y minus 7. One more step to get y by itself. I'm going to add 7 to both sides. That cancels out. Now, all in one go, y plus 2 cubed, add 7 is equal to y. And that is our final equation in order to get y by itself. Tips for this group: you want to make sure you get the cube root or the square root by itself first, just like we did with our absolute value and our higher power parentheses. And again, making sure you're doing the inverse operations, adding and subtracting, multiplying and dividing in order to get the y by itself. Let's say, for instance, and I'll do it in a different color to show, if there was still a 7 coefficient in front of the y, I would need to divide both sides by 7, and then everything would get divided. So even if this one didn't have a coefficient in front of the y, even if your problem does, still make sure you're completing all of your inverse steps to get y completely by itself. There should be only a 1 coefficient in front of the y like we have here. Okay.